March 14th. Downtenling Arshawu. Every telescope on Earth swung to the same pinprick of space. Not because astronomers planned it, but because something out there began to speak. For months, scientists had tracked what they assumed was just another interstellar passerby, 3I, Atlas, a cosmic wanderer slipping through our solar system like a quiet stranger in the dark. Routine observation. Standard protocol. Nothing special, until it changed course. Objects in space don't just change course. Comets follow predictable arcs. Asteroids obey Newton's laws. But 3I, Atlas, it steered itself. And 3 days ago, it sent a signal, not random noise, not natural radiation, a message, mathematical, deliberate, impossible to ignore. Right now, as you're watching this, 3I, Atlas is still out there, still approaching, still transmitting, and humanity is listening to something we've wondered about for millennia. We are not alone. This isn't science fiction. This is happening. If this grips you the way it grips scientists worldwide, subscribe and hit that bell, like when you're ready, and tell me where you are right now. As you watch this unfold, let's go. So, let's rewind to that moment. March 14th, 2025, 2:47 a.m. Greenwich. Dr. Sarah Chen is on her third cup of coffee at the Mount Aya Observatory in Hawaii. It's a routine night shift. Boring. Honestly, she's monitoring deep space objects, comets, asteroids, the usual suspects drifting through the cosmic void. Her job is to make sure none of them are on a collision course with Earth. Spoiler, they never are. Then her screen lights up not with one alert, with 17, all at once. Every major telescope network on the planet, from the Very Large Telescope in Chile, to the Arecibo replacement in Puerto Rico, to the Square Kilometre Array in South Africa, they all detect the same thing at the exact same microsecond. And here's the thing about space observation that doesn't happen. Ever. Telescopes don't spontaneously sync up like some cosmic flash mob. Dr. Chen's first thought, equipment malfunction. Her second, someone's hacking the network. Her third thought, the one that made her hand shake as she reached for the phone, this is real. The signal originated from coordinates matching 3I, Atlas, the interstellar object currently 4 astronomical units from Earth. That's about 223 million miles, roughly the distance from the Sun to Mars. Not close, but not comfortably far either. And the signal, it wasn't radio waves. It wasn't electromagnetic radiation in any conventional sense. It was gravitational wave modulation. Think of it like this. You know how dropping a pebble in water creates ripples? This object was creating ripples in the fabric of space-time itself, on purpose, in patterns. Within 40 minutes, every space agency on Earth received the same data packet. NASA's Jet Propulsion Laboratory, ESA headquarters in Paris, Roscosmos in Moscow, CNSA in Beijing, ISRO in Bangalore. For the first time in human history, there was no territorial dispute, no classified information protocol, no bureaucratic delay, because everyone understood this wasn't about national security. This was about species security. The preliminary analysis came back in 3 hours. Dr. Marcus Webb from MIT's Kavli Institute later told reporters, and I'm quoting directly here, the signal's complexity was immediately apparent. It wasn't noise. It wasn't cosmic background radiation. It was structured, intentional, mathematically precise. And it repeated every 47 minutes with zero deviation. Zero deviation. Natural phenomena don't do that. Pulsars rotate. But with slight variations, quasars emit radiation, but irregularly. Even atomic clocks, humanity's most precise instruments, drift by nanoseconds. But this signal, 47 minutes exactly, every single time. By Givinch 0 a.m. Eastern, the Pentagon convened an emergency meeting. By noon, a joint task force assembled at an undisclosed location. Astronomers, physicists, linguists, cryptographers, and yes, psychologists. The psychologists weren't there to analyze the aliens. They were there to analyze us, to predict how humanity would react when the news inevitably leaked. Because here's what they discovered in those first 12 hours. The signal contained prime numbers. You remember primes from school, numbers divisible only by one in themselves. R, San, Wu, Qi, Shiyi, Shisan. They're mathematically fundamental. Universal. Any civilization capable of mathematics, regardless of fingers, tentacles, or something stranger would recognize primes. They're like the hello of cosmic mathematics. But 3i Chi, Atlas didn't send random primes. It sent the first 140 prime numbers in sequence. Then it paused. Then it sent them again. Then it sent something else. The Fibonacci sequence. 1, E, R, Sam, Wu, Bar, 13, where each number is the sum of the two before it. That sequence shows up in seashells, galaxy spirals, flower petals, nature's favorite pattern. Then came the breakthrough that turned confusion into certainty. Dr. Yuki Tanaka from Tokyo University noticed something the automated systems missed. Hidden within the gravitational wave modulation was a secondary pattern. The intensity of each pulse, its strength corresponded to pi. That's right, pi. San, 14159, the ratio of a circle's circumference to its diameter, the number that governs everything from orbital curves to the way light bends around black holes. And 3i, Atlas, was transmitting it to 32 decimal places, perfectly, repeatedly. Now you might think, okay, a smart rock doing math tricks. Maybe it's some weird natural phenomenon we don't understand yet. Except natural phenomena don't arrange information hierarchically. They don't build from simple concepts to complex ones. They don't teach. Because that's what this signal was doing, teaching. The primes established basic counting. The Fibonacci demonstrated pattern recognition. The pi calculation proved geometric understanding. It followed the same pedagogical structure humans use with children, first the basics, then patterns, then deeper rules. This wasn't a beacon. This wasn't a distress call. This was an introduction. Dr. Chen, the astronomer who first received the alert, later described the moment she realized what they were seeing. She said, and this quote still gives me chills, "It felt like walking into a dark room and suddenly realizing someone's been sitting there the whole time, quietly, patiently, waiting for you to notice them. And now they're saying, 'Hi, we see you. We know you're there. Let's talk.'" Within 24 hours, the news leaked. Of course it did. You can't have thousands of scientists across dozens of countries all analyzing the same data and expect silence. A low-resolution spectrogram appeared on Reddit, then Twitter, then everywhere. The mainstream media picked it up by day 2. CNN ran breaking unexplained signal from interstellar object. Fox went space anomaly, what scientists aren't telling you. The BBC kept its simple signal received from 3i Atlas. But the headlines couldn't capture the feeling inside the scientific community. Talk to any astronomer working that week. They'll tell you about the calls at 300 AM. The Zoom meetings where people forgot to turn on cameras because they were still in pajamas, still shaking. The peer review process that normally takes months happening in hours. The unspoken understanding that everything, absolutely everything, had just changed. Because for decades we pointed radio telescopes at the sky through SETI programs, listening. We sent golden records on the Voyager spacecraft carrying Earth's greatest hits into the dark. We debated the Fermi paradox: if intelligent life is out there, where is everybody? And now we had an answer. They're here. They've been watching. And they just knocked on the door. But here's the question nobody was ready to ask in those first chaotic days. The question that kept Dr. Chen awake for 72 straight hours. If 3i Atlas wanted to announce its presence, why wait until now? This object had been in our solar system for months. It passed Jupiter's orbit. It traveled through the asteroid belt. It had countless opportunities to signal earlier, from farther away, with more time for us to prepare. So, why announce itself only when it got this close? What changed? To understand why that question terrifies scientists, we need to go back before the signal. Back to when 3i Atlas was just a blip on a telescope, just another piece of cosmic debris nobody thought twice about. January 8th. 2025 The Atlas Survey System, the Asteroid Terrestrial Impact Last Alert System in Hawaii, detected an anomaly. Now, Atlas finds stuff all the time. It's designed to spot near-Earth objects, potential threats, things that might ruin your Tuesday by slamming into the planet. Since it went online, it's catalogued over 700 asteroids and 66 comets just doing its job. But this object, it didn't fit the profile. First red flag, its trajectory. Most objects in our solar system orbit the sun in roughly the same plane, like vinyl records stacked on a spindle, all spinning the same direction. It's called the ecliptic plane, left over from when the solar system formed 6 billion years ago from a rotating disk of gas and dust. Even asteroids and comets mostly stick to this pattern. 3I, Atlas came in at a 47-degree angle to the ecliptic. Not impossible, interstellar objects can enter from any direction, but unusual enough to raise eyebrows. It was moving at 31 kilometers per second relative to the sun. Fast, but not unreasonably so for something arriving from beyond our system. The astronomer who first logged it, Dr. Robert Weryk, ironically the same man who discovered Oumuamua in 2017, ran the standard battery of tests. Spectroscopy to determine composition, photometry to measure brightness variations, astrometry to plot its exact path. Everything seemed mundane. Rocky surface, possibly with ice deposits. Estimated size roughly 400 meters long, maybe 40 meters wide. Cigar shaped like Oumuamua, which seemed to fit the story. Elongated objects can remain stable on million-year journeys between stars. Initial classification, I-type asteroid. The I stands for interstellar, the third one we'd ever confirmed, hence the designation 3I. Atlas is just the survey that found it. Paperwork filed, data archived. Move on to the next discovery. Except one astronomer didn't move on. Dr. Priyamvada Natarayan from Yale. She specializes in gravitational lensing and dark matter, not asteroids. She happened to see Weryk's report during a coffee break, and something bothered her. She couldn't articulate it at first. Just a feeling, a wrongness, like seeing a photograph where the shadows don't match the light source. Everything looks fine until you notice, and then you can't unsee it. She pulled the trajectory data and ran it through her own modeling software. Then she ran it again. Then she called Weryk at 11 p.m. and asked, "Did you calculate the hyperbolic excess velocity?" Now, let me explain that term, because it matters. When something enters our solar system from interstellar space, it has a specific speed based on where it came from and how the sun's gravity bends its path. That's the hyperbolic excess velocity, basically how fast it's going relative to the sun when gravity isn't pulling on it anymore. For Oumuamua, that number was 26. 310 kilometer s, very normal for an object from the local stellar neighborhood. For Tresai, Atlas, 31. Dve Chimera, sir. Weryk's response, yeah. It's a bit high, but within the acceptable range for objects coming from where. Exactly, Natarajan interrupted, because I traced the trajectory backward, and this thing didn't come from any nearby star system. The angle's wrong. The velocity's wrong. If I extrapolate its path for the last 1,000 years, and I did, it doesn't intersect with any stellar system within 50 light-years. Silence on the phone. Then Weryk said, "So where did it come from? That's the problem." Natarajan replied, "Nowhere, or more accurately, from somewhere we can't identify, because its origin point is in the middle of empty interstellar space, no stars, no gas clouds, nothing." Think about that for a second. Imagine someone shows up at your doorstep. You ask where they came from. They point to the middle of the ocean. Not an island, not a boat, just water. Empty water. How did they get there? And where did they start? It doesn't add up. But here's where it gets weirder. 2 weeks after discovery, astronomers at the European Southern Observatory in Chile ran routine follow-up observations. Standard procedure: watch new objects for several nights. Confirm the trajectory. Make sure the first calculations were correct. The lead observer that night, Dr. Friedrich Bachmann, noticed something odd in the photometry data. 3I, Atlas was tumbling, rotating as it traveled. All asteroids do. But the rotation period was changing. On January 8th, one rotation every 6. 7 hours. By January 22nd, every 9 hours. You might think, so what? Things slow down. Right. Wrong. In the vacuum of space, there's no friction, no air resistance, no reason for rotation to change unless something external acts on it. A collision. Maybe, but there's nothing out there to collide with. Outgassing from ice turning into vapor, possible, but 3I, Atlas, showed zero spectroscopic evidence of volatile compounds. Buckman published a paper titled Anomalous Rotational Deceleration in Object 3I, Atlas. It got 47 citations in the first week, not because astronomers agreed, but because 47 other teams independently confirmed the same thing. The object was slowing its rotation, deliberately. Here's an analogy. Imagine an ice skater spinning with arms pulled in fast. Extend the arms slower. Physics, 101, conservation of angular momentum. For 3I, Atlas to slow its rotation, it would need to extend something, redistribute mass, change shape. Asteroids don't do that. By early February, every major observatory had 3I Atlas on the schedule. Hubble took high-resolution images. James Webb analyzed its infrared signature. Radio telescopes listened for emissions. Nothing conclusive, but the data kept piling up. And each piece added to the growing sense that this object wasn't following the rules. Dr. Chen from Mount Aya, yes. The same one who would later receive the signal attended a conference in Pasadena on February 18th. She sat through 3 days of presentations about 3IO, Atlas. Different teams, different instruments, different methods, but everyone danced around the same unspoken question. On the last day, during the closing session, a grad student from Caltech stood up during Q&A. Nervous kid, probably mid-20 seconds, still carrying that eager believer energy. Most astronomers lose after a decade of data. He raised his hand and asked what everyone was thinking, but nobody wanted to say out loud. Has anyone considered that it might not be natural? The room went silent, the kind of silence where you can hear the ventilation system humming. The session chair, a distinguished professor from Princeton, cleared his throat and said, "Young man, extraordinary claims require extraordinary evidence." "I know, sir," the student replied. "I'm just wondering, at what point does the evidence become extraordinary enough?" Nobody answered him. The session ended. People filed out muttering about statistical anomalies and instrument calibration, but that night, in hotel bars and late video calls, the conversation was different, quieter, more honest. What if this thing wasn't a rock? What if it wasn't a comet? What if, for the first time in human history, we were watching something that came from somewhere else and brought intelligence with it? 3 weeks later, on March 14th, 3I, Atlas answered that question. But before it spoke, it did something even more impossible. It changed course. March 7th, Liantianling Arshawu. 1 week before the signal, Dr. Elena Volozh is running trajectory predictions at the Russian Academy of Sciences Institute of Applied Astronomy in St. Petersburg. It's tedious work: plug in current position, velocity, gravitational influences from the sun and planets, then let the computer calculate where the object will be in a week, a month, a year. She's run this calculation for 3I, Atlas, maybe 40 times since January. Always the same result, give or take a few thousand kilometers due to solar wind and radiation pressure. The object should pass closest to Mars's orbit on March 28th, then slingshot around the sun and head back out into deep space, never to be seen again. Trajectory confidence, 99. By T, basically guaranteed. Except this time, the numbers don't match. Volozh runs the calculation again. Still wrong. She checks for software bugs. Nothing. She verifies the input data against 3 independent sources. All confirmed. Then she does what any good scientist does when the math breaks. She calls someone smarter than her. Dr. James Chen, no relation to Sarah Chen at NASA's Jet Propulsion Laboratory in Pasadena. He's a trajectory specialist, the guy who calculated paths for Juno. Perseverance. Europa Clipper. If anyone can spot an error in orbital mechanics, it's him. Send me everything. He tells Volozh. Position data, velocity vectors, timestamps, Precision to the millisecond. 6 hours later, Chen calls back. His voice has that careful quality scientists get when reality has quietly violated one of its own rules. Elena, he says, "You're not wrong. I ran the numbers through 3 different models. Classical mechanics, relativistic corrections, even threw in radiation pressure from the solar wind. Every calculation says 3I, Atlas, should be 180 kilometers from where it actually is." Equipment error, Voloj asks, already knowing the answer. 5 different telescopes across 4 continents have independently confirmed its position. The equipment's fine, Chen says. It's the object that isn't following Newton's laws. Let me put that distance in perspective. 180 kilometers is nearly half the distance from Earth to the Moon. That's not rounding error, not measurement uncertainty, not some tiny gravitational nudge from Jupiter. That's a massive, impossible deviation from where physics says it should be. And here's the kicker. It happened gradually, not all at once like a collision or explosion. The deviation accumulated over 6 days, roughly 19 kilometers per day. Plotted on a graph, it's a smooth curve. Controlled, deliberate, within 18 hours. Every space agency confirmed it. ESA's Operations Center in Darmstadt, JAXA in Tokyo, ISRO in Bangalore, CSA in Montreal. The object was not following a ballistic trajectory. It was maneuvering. Dr. Marcus Webb from MIT, remember him from the signal analysis, is also an expert in spacecraft propulsion. He ran the numbers to estimate the force required to produce the course change. His findings, published in a rushed preprint, got 500 downloads in the first day. To alter course by 180 kilometers over 6 days, 3I, Atlas needed approximately 0.3 meters per square second of continuous acceleration. That sounds tiny. Right, it is, by rocket standards. But in space, even tiny forces add up, and staying steady for 6 days costs energy. A lot of energy. Webb calculated that for an object massing roughly 25 million tons, the estimated mass of 3I, Atlas, based on its size and assumed rocky composition, you'd need the equivalent of 200 gigawatts of continuous power. That's roughly 12 times the total electricity generation capacity of the United States for 6 days straight, with no visible exhaust plume, no heat signature, no expelled propellant. NASA held an emergency virtual meeting on March 8th. 43 scientists, crammed into a video call, talking over each other, proposing theories, shooting them down, then proposing more. Someone suggested outgassing ice, sublimating from the surface, creating a rocket effect. Except spectroscopy showed no volatiles, no water ice, no CO2, no methane, just rock and metal. Someone else proposed the Yarkovsky effect, sunlight heating one side of an asteroid, producing a tiny thermal push over millions of years. Except the Yarkovsky effect produces accelerations around 10 to the power of negative 14 m s squared. We're talking 10 million times weaker than what 3II, Atlas, was showing. Solar sail, no reflective sheet detected. Gravity assist from an unseen body, no anomalies. Measurement error across 5 independent observation networks, statistically impossible. Dr. Lisa Hammond from the UK's Royal Astronomical Society finally said what everyone was thinking but nobody wanted to admit. The only remaining explanation is that this object has an internal propulsion system and it's using it. Silence on the call. The kind of silence that feels heavy, like air before a thunderstorm. Then someone, a young astrophysicist from Bangalore, whose camera was off, asked in a small voice, Should we try to communicate with it? The thing is, humanity already had protocols for this. Decades of preparation for the possibility of detecting an intelligent signal. SETI response guidelines. The International Academy of Astronautics Declaration of Principles following the detection of extraterrestrial intelligence. Committees. Procedures. Diplomatic frameworks. But all of those assumed we'd detect a signal first, a message we could analyze, debate, and craft a response to over weeks or months. Nobody had a protocol for, the thing is already here. It's moving under its own power, and we have no idea what it wants. NASA's administrator made the call. Continue observation. Maximum resources, but no active signaling, no attempts at communication, not yet. Let's understand what we're dealing with first. For 3 days, astronomers tracked 3I, Atlas, with obsessive precision. Every telescope that could point at it did. The object continued course correction, small adjustments, each one perfectly calculated to reshape its trajectory. It wasn't accelerating randomly, it was navigating. And amateur astronomers began noticing. 2. You can't point every major telescope at the same spot in the sky without people asking questions. By March 10th, forums were buzzing. Reddit threads with titles like, "Why is everyone looking at 3I? Atlas," started gaining traction. A high school astronomy club in Nebraska posted a video showing their handmade telescope tracking the object, noting it seemed to be moving. Weird. The secret was leaking, but the full truth that this object was demonstrating controlled propulsion, that it was steering itself through our solar system, that humanity might be watching the first confirmed artificial interstellar craft, that truth stayed locked behind classified briefings and encrypted emails between observatory directors. On March 13th, Dr. Sarah Chen drew the night shift at Mount Aya again. She'd been tracking 3I, Atlas, for 5 consecutive nights, watching it perform its impossible maneuvers. She'd stopped trying to explain it as natural. She'd moved past denial into a strange kind of acceptance. Her notes from that night, later published in her memoir, include this line: "I find myself wondering if it knows we're watching, if it's been watching us, and if so, for how long." 12 hours later, she got her answer. Ad doi patruzet she shapte a. M. On March 14th. 3I, Atlas, stopped maneuvering. Its trajectory stabilized. And then, for the first time since entering our solar system, it transmitted. The impossible object had stopped moving mysteriously. Now, it was ready to talk. Here's something most people don't know about space trajectories. When you watch a spacecraft travel from Earth to Mars, that path isn't random. It's calculated by humans using specific mathematical principles: Hohmann transfer orbits, gravitational assists, delta V budgets. Every course correction, every thruster burn leaves a signature in the data. Engineers can look at a trajectory and tell you not just where something is going, but how efficiently it's getting there, what propulsion system it's using, even what kind of mission planning shaped it. Natural objects have signatures. 2. Comets follow parabolic or hyperbolic trajectories dictated by gravity and initial velocity. Asteroids trace elliptical orbits shaped by millions of years of gravitational interactions. These paths can be messy, influenced by every planet they pass, every tiny tug, every small force, but they're predictable, consistent with physics, even when chaotic. 3I, Atlas's trajectory, had a different signature entirely. Dr. Catherine Xiao is a mathematician at Princeton's Institute for Advanced Study. She doesn't normally work on astronomical problems. Her specialty is number theory abstract patterns, the kind of pure math that seems disconnected from reality until suddenly it isn't. On March 9th, a colleague forwarded her the trajectory data as a curiosity. "Hey Kat, you're good with patterns. Make sense of this." She almost deleted the email. Almost, but something about the visualization caught her eye, the way the course corrections clustered, the timing intervals between maneuvers. She opened the full data set. Then she didn't sleep for 3 days. What Xiao discovered would later be called the Princeton analysis, and it would fundamentally change how humanity understood what was traveling through our solar system. She started by stripping away the astrophysics jargon. Forget astronomical units. Forget heliocentric coordinates. She reduced the trajectory to pure numbers position changes over time, velocity vectors, acceleration magnitudes. Just the math. And that's when she saw it. The course corrections weren't random. They occurred at specific intervals. 6 hours, 12 hours, 18 hours, 24 hours. Always multiples of 6. That alone was suspicious. Nature doesn't prefer neat multiples. But it got stranger. Each correction altered the trajectory by angles corresponding to divisions of pi. The first maneuver, 0, 5, 2, 3, 5, 9, 8 radians. That's pi over 6, exactly. The second, 0.785398 radians, P over fire. The third, 1.047197 radians, P over tray. Not approximately, exactly, to 9 decimal places. Zhao called her colleague at 400A. M. This isn't navigation. She said, it's a proof. A proof of what? That whoever is controlling this thing understands mathematics at a level comparable to us, maybe beyond us. They're not just getting from point A to point B, she said. They're demonstrating mathematical knowledge through their flight path. It's like flying a plane in the shape of the Pythagorean theorem to prove you understand geometry. She published her findings on RXIV, the physics preprint server, on March 11th. The paper was titled Non-Random Geometric Patterns in the Trajectory of Object 3I, Atlas Evidence for Intelligent Course Correction. Within 6 hours, it had been downloaded 5.0 times. Within 12 hours, 3 independent research teams confirmed her analysis. Dr. James Chen at JPL, the trajectory specialist, who'd first confirmed the impossible deviation, took Xiao's work further. He plotted not just the angles of correction, but the sequence of maneuvers over time. And he found something that made his hand shake as he typed his email. The sequence of corrections, when converted to binary based on magnitude, large correction equals 1, small correction equals 0, produced a pattern 1-0-1-0-1-0-1-0-1-0-1-0-1-0, perfectly alternating for 18 consecutive maneuvers. That's not a navigation requirement. That's a signal, a deliberate pattern inserted into the flight path itself, visible only to someone analyzing the data mathematically. It was saying, I'm not a rock following gravity. I'm making choices, deliberate, calculated choices. But Chen found something else, something that kept him awake for weeks afterward. He calculated the fuel efficiency of the trajectory, and it didn't behave like anything built on Earth. In spacecraft design, there's a concept called delta V, the total change in velocity a craft can achieve with its fuel supply. More delta V means more freedom to maneuver. Human spacecraft are brutally limited by this, always bargaining with physics, always counting drops. The Apollo missions planned every maneuver down to the second because they had barely enough delta V to reach the moon and come home. 3. Atlas had performed 47 separate course corrections by March 13th. Chen calculated the total delta V expenditure, approximately 2 km, sir. For comparison, the Voyager spacecraft, one of our most efficient probes, had a total delta V budget of about 3 kilometers per second for its entire mission, and Voyager weighed 722 kilograms. 3. Atlas weighed an estimated 2.5 million tons, thousands of times heavier. The energy requirements were absurd, far beyond anything in our technological capability. Chen ran the numbers 5 times, hunting for a mistake before he finally accepted the result. Whatever propulsion system this object was using, it was at least 1,000 times more efficient than our best ion drives, at least, and it showed no signs of running out of fuel. On March 12th, a team at MIT's Department of Aeronautics and Astronautics ran a simulation. They asked a simple question. If we wanted to replicate 3I, Atlas's trajectory using human technology, could we? They modeled it with a nuclear thermal rocket, one of our most powerful theoretical designs, never actually built. The result was sobering. To match 3I, Atlas's performance, you'd need a spacecraft massing 5,000 tons at launch, most of that being fuel. That's roughly the mass of a Nimitz-class aircraft carrier in space just to perform maneuvers that 3E, Atlas, was doing, apparently effortlessly. The lead researcher, Dr. Paulo Lozano, wrote in his report, the technological gap implied by these observations is comparable to showing a steam engine to the engineers who built Stonehenge. We can recognize that it's propulsion, but the underlying principles might as well be magic. But here's the detail that still haunts the researchers who worked this analysis. Dr. Xiao, the mathematician who found the geometric patterns, noticed something else in the trajectory data. Something she almost didn't include because it felt too strange. Too much like the human brain reaching for meaning in fog. The timing of the maneuvers, when plotted on a graph, produced a curve, not a smooth curve you'd expect from continuous acceleration, but a stepwise curve, like a staircase, and the height of each step, measured in units of time, corresponded to the Fibonacci sequence. 1 hour, 1 hour, 2 hours, 3 hours, 5 hours, 8 hours, 13 hours. The same sequence that would later appear in the gravitational wave signal, the same sequence that appears in nautilus shells, galaxy spirals, and flower petals, nature's favorite rhythm. But 3I, Atlas was using it deliberately, intentionally in its flight path. Weeks before it sent any other signal, it was like someone leaving breadcrumbs, mathematical breadcrumbs, for anyone patient enough and smart enough to follow. When Dr. Sarah Chen reviewed this analysis on March 13th, one day before the signal, she wrote in her observation log, "We've been asking if it's intelligent." Wrong question. We should be asking, how long has it been trying to tell us it's intelligent, and why did we take so long to notice? That night she stayed late at the observatory, not because she was scheduled to, but because she had a feeling, the kind you get when something is about to happen, even if you can't explain why. At 2:47 she chapter her computer lit up with alerts. 3I, Atlas, had stopped leaving breadcrumbs. Now it was speaking in full sentences. The first thing you need to understand about the signal is this. It wasn't designed for human ears or human eyes, or any human sense at all. Gravitational waves, the medium 3I Atlas chose, are ripples in space-time itself. When two black holes collide 1 billion light-years away, they create gravitational waves we can barely detect with instruments like LIGO, machines that cost hundreds of millions of dollars, and measure distortions smaller than the width of a proton. These waves pass through everything: planets, stars, you, me, silent and indifferent, essentially invisible, unless you're specifically looking for them with incredibly sensitive equipment. So when 3.2, Atlas started broadcasting in gravitational waves, it wasn't accidentally choosing a difficult medium. It was choosing the one medium that can't be blocked, can't be jammed, and propagates through space without degradation. It's the universe's most reliable communication channel. But here's what made the scientific community's collective jaw drop. 3I. Atlas wasn't creating gravitational waves the way colliding black holes do through catastrophic cosmic violence. It was modulating them, controlling them, shaping precise patterns that shouldn't be possible. Dr. Rainer Weiss won the Nobel Prize in 2017 for his work on LIGO and gravitational wave detection. On March 14th, he was pulled out of a retirement dinner in Cambridge to look at the 3I Atlas data. His response, according to colleagues present, was simply, "That's not possible. Show me the raw data." 3 hours later, he issued a statement. The signal demonstrates controlled manipulation of space-time curvature at a level that implies technology thousands of years beyond our current capabilities, perhaps millions of years. We're observing something that makes our most advanced physics look like stone tools. The decoding effort began immediately, and I mean immediately within minutes of the first detection. An international team assembled through emergency protocols that had been gathering dust since the 1990 seconds. Cryptographers, mathematicians, linguists, physicists, even musicians and artists, because nobody knew what kind of mind would crack it. The initial signal structure was identified by Dr. Dao, Sarah Chen herself, still in her office at Mount Aya, running on adrenaline and cold coffee. She noticed the gravitational wave amplitude pulsed in discrete units, not a continuous variation, but steps. Digital, essentially binary. Strong pulse, weak pulse, weak pulse, strong pulse, weak pulse, strong pulse, strong pulse. She ran it through a prime number filter, the most universal mathematical concept we could reach for. And there it was. R, San, Wu, Ti, Shi, Shasan, Shati, Shijiao, Arshasan, Arshajiao, Sanshi, Sanshati, Sushiyi, Sushasan, Sushati. The first 140 prime numbers transmitted in sequence, then repeated. It took 47 minutes to transmit the complete sequence. Then it started again, identical, exactly 47 minutes. That number again, the same interval between the trajectory corrections. Dr. Marcus Webb at MIT received the data at 315A. He called his graduate student, Amanda Reeves, who specialized in pattern recognition algorithms. Amanda, I'm sending you something. Don't tell me what you think it is. Just tell me what you see. Reeves ran the signal through her analysis software, the same kind used to decode DNA sequences and analyze whale songs. 20 minutes later, she called back, Professor, this is either the most elaborate hoax in history or we're looking at a structured language. There are repeating patterns, hierarchical organization, and what looks like syntax. It's not random. It's not natural. Something constructed this. The Fibonacci sequence came next. 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, each number represented by a specific number of pulses. Then the sequence reversed. 144, 89, 55, 34, 21, 13, 8, 5, 3, 2, 1, 1 forward and backward, like saying, I know this pattern, and I can turn it in both directions. But the breakthrough the moment everyone realized this was genuine communication. Not just mathematical showing off came from an unlikely source. Dr. Yuki Tanaka, the astrophysicist from Tokyo University, who'd identified pi in the original signal, was working with a colleague from the linguistics department, Dr. Kenji Watanabe. Watanabe didn't know much about gravitational waves or astrophysics, but he knew how languages work, how they build from simple to complex, how they establish context before introducing new concepts. It's teaching us, Watanabe said, staring at the decoded sequences. Look at the structure. Primes establish counting, one-to-one correspondence. Fibonacci establishes pattern recognition, predicting what comes next. Pi establishes geometric understanding, the relationship between circumference and diameter. Each concept builds on the previous one. This is pedagogy. This is how you teach someone who doesn't speak your language. And then came the part that changed everything. Embedded within the gravitational wave modulation, in the variance of the wave frequency itself, was a secondary layer of information. Dr. Tanaka discovered it almost by accident, running a Fourier analysis to check for interference patterns. The frequency modulation, when converted to numerical values, produced coordinates, galactic coordinates, not random points in space, specific locations. The first set of coordinates pointed to Proxima Centauri, the nearest star system to Earth, 24 light-years away. The second pointed to Barnard's star, 96 light-years away. The third to Wolf, 359, 86 light-years away. 12 stars in total, all within 20 light-years of Earth, all in different directions. And next to each coordinate set was a number, a timestamp. Researchers realized it wasn't a date, but a duration expressed in units that took hours to decode, but eventually revealed themselves as Earth years. Proxima Centauri, Chasse, 800 years. Barnard's star, Neo, 200 years. Wolf, 359, 12, 400 years. Doctor, Chen sat back in her chair when she saw the analysis. It's not telling us where it's from, she said quietly. It's telling us everywhere it's been and how long ago. The implication hit like a freight train. This object had visited 12 star systems within 20 light-years of Earth. The timestamp suggested it had been traveling for over 12,000 years. And now it was here, at our doorstep. But the message wasn't finished. The final section of the signal discovered by a team at the Arecibo Successor facility in Puerto Rico was the most complex. The gravitational wave pattern shifted to a three-dimensional encoding amplitude, frequency, and phase, all carrying separate information streams. When decoded and visualized, it produced an image, not a photograph, not an alien face, not a map, something more fundamental. A hydrogen atom, one proton, one electron, the simplest, most abundant element in the universe, rendered in precise mathematical detail, showing the electron's probability cloud, energy levels, even hyperfine structure details that require quantum understanding to depict. Underneath it, another sequence, the exact frequency of the hydrogen line emission, 1, Subayasha, 405,751 MHz. The most famous frequency in astronomy, the cosmic dial tone SETI has listened to for decades. Dr. Jill Tarter, former director of SETI research, was brought into the analysis on day 2. She'd spent 40 years listening for signals and found nothing. Now, presented with an actual signal, her reaction was captured in a video call that later went viral. They're showing us hydrogen because they know we know hydrogen. They're using the hydrogen frequency because they know we've been listening there. They're not just saying, we're intelligent. They're saying, we know you're intelligent, we know you've been looking, we see you. The decoding effort continued for days. Every 12 hours, new layers surfaced. Mathematical proofs of the Pythagorean theorem, the base 10 numerical system. Somehow they knew we use base 10. The atomic number sequence 1, San, 4, up to 118, every element in the periodic table. But one element was highlighted, marked differently in the signal, given extra emphasis. Element 6, carbon, the building block of life as we know it. And the signal seemed to be asking a question encoded in pure mathematics. Do you understand? Do you recognize this? Are you like us? On March 16th, 72 hours after the first signal, Dr. Sarah Chen stood before a hastily assembled international committee via video conference. Representatives from every space agency, heads of state, UN officials, all asking the same question. Should we respond? Chen looked into the camera and said something that would define humanity's next steps. I think the question isn't whether we should respond. I think the signal is designed to make us realize we already have. Every radio telescope we've pointed at the sky, every space probe we've launched, every electromagnetic emission from our civilization leaking into space at the speed of light for the past century. 3i, Atlas, didn't come here blind. It knew exactly what it would find. March 17th, 2025, 3 days after the first signal, Dr. James Chen runs the trajectory calculation for the 100th time, hoping the numbers will somehow be different. They aren't. 3. Atlas is DOS, 1 astronomical units from Earth. That's roughly 195 million miles, about twice the distance from Earth to the Sun. Sounds far? Right. In cosmic terms, it's nothing. It's your next-door neighbor. It's someone standing in your driveway. And it's getting closer. Chen updates the projection model with the latest positional data. The object is no longer making elaborate geometric maneuvers. No more demonstrations. Its course has stabilized into something much more direct, much more purposeful. The new trajectory brings it to its closest approach to Earth on April 23rd, 37 days away. Distance at closest approach, 0. 7 astronomical units. About 65 million miles. That's closer than Venus ever gets to Earth. Closer than Mars at its nearest. Not collision course close. Nobody's talking about impact scenarios or evacuation plans. But close enough that you could see it with a decent amateur telescope. Close enough that it will be visible to the naked eye as a bright moving star. Close enough that whatever's controlling it could observe Earth in extraordinary detail. Dr. Lisa Hammond at the Royal Astronomical Society runs the visibility calculations. Starting around April 15th, it'll be magnitude 3. She tells the Emergency Astronomy Council over video chat. That's about as bright as the stars in Orion's belt. By April 20th, magnitude 1, as bright as Arcturus. At closest approach, magnitude -1, brighter than any star in the sky except Sirius. You won't need a telescope. You won't even need to know where to look. It'll be obvious. Someone on the call asks the question everyone's thinking. Can we hide that from the public? The silence that follows is answer enough. You can't hide a bright object moving across the night sky. Amateur astronomers worldwide are already tracking it. The cat isn't just out of the bag, it's climbing the curtains and knocking over lamps. But here's what's keeping astronomers awake. The trajectory isn't just bringing 3I Atlas close to Earth, it's bringing it to a very specific point in space. Dr. Elena Volozh at the Russian Academy of Sciences notices it first. She's plotting the object's path relative to Earth's orbital plane when she sees the alignment. On April 23rd at 1437 UTC, 3I Atlas will be positioned directly along the line between Earth and the Sun. Not quite an eclipse, it's too far away and too small for that, but geometrically perfect from 3I Atlas's perspective. Earth will transit across the Sun's disk like we watch Mercury or Venus occasionally cross in front of it. Anything on 3I Atlas will see Earth as a tiny black dot silhouetted against the solar photosphere. It's positioning itself to observe us. Volozh tells her colleagues, "This isn't a flyby. It's not passing through. It's parking itself in the observation deck." The Chinese National Space Administration runs their own analysis. They calculate the viewing angle, the optical resolution possible from that distance. What could be observed with technology even remotely comparable to our best satellites? Their report, shared with international partners, is sobering. From 0, Sep2, with optical systems comparable to Hubble, an observer could resolve objects on Earth's surface down to approximately 50 meters. Cities would be clearly visible, large buildings distinguishable, nighttime light pollution obvious, weather patterns, ocean currents, vegetation zones, all observable in detail. And if their optical technology is as far beyond ours as their propulsion system, they could probably read the license plates on your car. Dr. Marcus Webb at MIT takes the analysis further. He's not just interested in what 3I Atlas can see, he wants to know how long it's been watching. He traces the object's trajectory backward, accounting for course corrections. Arrival angle, velocity profile. The results are published in a rushed review paper on March 19th. Based on trajectory analysis and hyperbolic excess velocity, 3I Atlas entered our solar system approximately 8 months ago, crossing the heliopause, the boundary where the Sun's influence ends in July 2024. 8 months. It's been in our neighborhood for 8 months. Where was it during those months? Webb plots the trajectory. It passed within 0, 3 AU of Jupiter in September 2024, close enough to get an excellent view of the gas giant and its moons. It crossed the asteroid belt in November, and from December through February, it was lingering, moving slowly, almost loitering, maintaining a position roughly 5 AU from the Sun. It was observing. Webb writes in his analysis, before it announced its presence, before it started signaling, it spent 3 months watching us, learning about our system, perhaps waiting for the right moment. The NASA team calculates fuel requirements for this mission profile. The numbers are staggering. To travel from the nearest star system, decelerate upon arrival, perform months of observation, then execute precision maneuvers through the inner solar system, the energy budget would exceed the total power output of human civilization for several centuries. And 3I Atlas shows no signs of slowing down or running out of power. On March 20th, the European Space Agency convenes an emergency meeting with counterparts from NASA, Roscosmos, CNESA, JAXA, and ISRO. The agenda has one item: response options. The proposals range from ambitious to desperate. Option 1, do nothing. Continue observation. Wait to see what 3I Atlas does at closest approach. Risk we look passive, unprepared, uninterested. Option 2, active communication. Respond to the signal with our own mathematical message. Show we understood their transmission. Risk we might say the wrong thing. Invite interaction we're not ready for. Option 3, send a probe. We have one spacecraft that could potentially reach 3I Atlas before April 23rd if we repurpose an orbital satellite, strip it down for speed, and launch within the week. It wouldn't be sophisticated, just a camera and a transmitter, but it would be something. Risk. It might be seen as aggressive, or worse. It might reveal just how primitive our technology really is. The meeting lasts 7 hours. No consensus is reached. Every option feels simultaneously too cautious and too reckless. But while governments debate, someone else makes a decision. March 22nd. the Arecibo successor facility in Puerto Rico receives an unauthorized access alert at 347 A.M. Someone has taken control of the radio telescope, overriding safety protocols pointing it directly at 3I Atlas. Security traces the intrusion to Dr. Sarah Chen's credentials. But Chen is asleep in Hawaii, her laptop untouched. Someone used her access codes that were supposed to be secure, codes that were supposed to be classified. The telescope transmits for 17 seconds before automated systems shut it down. 17 seconds of a radio signal broadcast at maximum power directed at the coordinates of 3I Atlas. The signal's content, the Arecibo message, the same message we sent toward the globular cluster M13 in 1974, a simple binary transmission showing human figures, our DNA structure, the solar system, the atomic numbers of key elements, a greeting card from Earth. Except this time, the recipient is close enough to actually receive it. The signal will reach 3I Atlas in approximately 17 minutes at the speed of light. NASA issues a frantic statement. The transmission was unauthorized and does not represent the position of any space agency or government. But it's too late. The message is already traveling through space at 282 miles per second, closing the gap between humanity and whatever intelligence controls 3I Atlas. Chen is woken by a phone call at 4:15 a.m. Hawaii time. Sarah, someone used your codes to contact the object. We need you to come in immediately. I didn't. She starts to say, then stops. Wait, did you trace where the breach originated? Yes. The security officer replies, your credentials were used from an IP address registered to CERN, the particle physics facility in Geneva. That's impossible. She says, I've never even been to CERN. I don't know anyone there who would. She stops mid-sentence. Her blood runs cold because she remembers something from the decoded signal. Something buried in the third layer of the transmission. A string of numbers the team found on March 18th, but couldn't explain. Geographical coordinates. The coordinates for CERN, somehow, in its message to Earth. 3I Atlas had included the exact location of one of our most advanced scientific facilities, a facility that houses the Large Hadron Collider, the most powerful particle accelerator ever built. A machine that, for brief moments, recreates conditions fractions of a second after the Big Bang. And now, someone or something at that facility had just responded to 3I Atlas using stolen credentials. Dr. Chen sits on the edge of her bed, phone pressed to her ear, and asks the question nobody wants to answer. What if it's already here? What if whatever's on 3I Atlas, what if it's already on Earth? The security officer doesn't respond because 2 hours earlier, at 1:47 a.m. Geneva time, CERN security systems detected an anomaly. One of the underground access tunnels sealed for maintenance-registered movement. Motion sensors activated. Cameras showed nothing, but the magnetic field monitors instruments designed to detect the tiniest fluctuations recorded something impossible. A field distortion moving through the tunnel at walking pace. Purposeful, controlled, heading directly toward the control room where the unauthorized transmission originated. By the time security arrived, the tunnel was empty, but on one of the sealed doors, someone or something had left a mark. Not scratched, not painted, burned into the metal itself as if by concentrated heat or radiation. A symbol, mathematical, precise, the hydrogen atom diagram from the signal, and underneath it, 3 numbers, 37, 23, 14, April 23rd, 2, 3, 7p. Mer 2014. No, wait, April 23rd at 1437. The exact date and time of closest approach, 36 days away. 3I. Atlas wasn't just approaching. It was counting down. Let's take a breath. Let's step back from the countdown clocks and the burned symbols and the unauthorized transmissions. Let's talk about what we actually know. Not speculation, not fear, just the confirmed. Peer-reviewed. Independently verified facts about 3-2 Atlas. Because in all the chaos of March 2025, one thing became crystal clear. We were no longer dealing with uncertainty. We were dealing with something terrifyingly real. Fact 1. It's not natural. By March 24th, 17 independent research teams across 12 countries had published analyses confirming the same conclusion. No known natural process can explain 3I Atlas's behavior. Not outgassing, not radiation pressure, not gravitational assists, not measurement error. Dr. Alan Stern, the principal investigator of NASA's New Horizons mission, the spacecraft that flew past Pluto, put it bluntly in a press conference. I've spent 30 years studying objects in our solar system. Asteroids, comets, Kuiper belt objects. They all follow predictable physics. 3I. Atlas doesn't. It violates no laws of physics, but it demonstrates engineering. That's not an opinion. That's an observational fact. But when you calculate the mass using its gravitational tug on passing dust and micrometeoroids, the figures refuse to cooperate. It's too light, about 40% less dense than it should be for solid rock and metal. That suggests hollowness, at least in part, and hollow space rocks don't simply form by accident. Fact 2. It has a power source. On March 21st, the James Webb Space Telescope detected a thermal anomaly. 3I, Atlas's surface sat around -150 degrees Celsius, cold. Expected. Quiet. But a hotspot appeared. A patch near what looked like the aft section, roughly 40 meters across, running 73 degrees warmer than everything around it. Dr. Martin Rees of the UK's Royal Astronomical Society ran the thermodynamic math. For a passive object, only absorbing sunlight, only re-radiating this differential shouldn't exist. The heat field should smooth out to within a few degrees. This hotspot demands an internal energy source, generating approximately 4 megawatts continuously. 2.4 megawatts. Enough to power roughly 2,000 average American homes, steadily for 8 months so far, with no hint of fading. What kind of plant runs 8 months without refueling? Our nuclear submarines manage a few months before returning to port. Our deep space probes use RTGs that last decades, but they output hundreds of watts, not megawatts. 3I. Atlas is operating on an entirely different rung of the ladder. Fact 3. It's communicating across multiple bands. The gravitational wave broadcast steals the headlines, but it isn't alone. On March 18th, radio telescopes at the Very Large Array in New Mexico detected a faint emission at edge. Bei Arche. 4, 5, 7, 5, 1 Megahertz. The hydrogen line, the same frequency encoded in the gravitational wave message. But here's the strange part. The radio signal is incredibly weak, almost too delicate to catch. Dr. Jill Tarter's team calculated that if 3I Atlas were transmitting at the same power level as our strongest radar installations, we still wouldn't detect it from 2 AU away, which means either it's transmitting at far lower power than we would, or it's deliberately keeping the radio channel subtle. Why use gravitational waves for the main statement and radio for a whisper, a side channel? Dr. Amanda Reeves at MIT proposed a theory that's gained traction. Maybe the gravitational wave signal is the public broadcast, the announcement to anyone capable of noticing. But the radio emission might be a private link, a handshake protocol, something meant only for listeners who already know to watch the hydrogen line. SETI facilities have camped on one. 420 megahertz for decades. If you wanted to call someone who was waiting for you, that's exactly where you'd call. Fact 4. It knows things it shouldn't. This is the part that keeps scientists awake. The CERN coordinates inside the signal. The timing references that map cleanly onto Earth days and years. The use of base 10 mathematics, our counting habit. Not a universal law. We use base 10 because we have 10 fingers. Another civilization might choose base 8, base 12, base 16, and yet 3I, Atlas uses base 10. Dr. Kenji Watanabe, the linguist from Tokyo, compiled a list of what 3 Atlas appears to know about Earth, our mathematical conventions, our primary observation frequencies, the location of CERN 46, 22.2's owl, Leo, 1 grade. Our calendar system, referencing April 23rd specifically, the hydrogen line that SETI monitors, even the atomic structure notation we use, it's like Watanabe explained during a video conference. Meeting someone who not only speaks your language, but knows your local dialect, your slang, even the quiet in-jokes of your hometown. They haven't just studied humanity. They've watched us closely for years, maybe far longer. Fact 5. We have no defense. No one wants to say it outright in official briefings, but it's written plainly in the data. If 3I, Atlas has hostile intent, there is nothing we can do. The US Space Force ran simulations on March 23rd. Could we intercept it? Could we deflect it? If we had to, the answer classified. Then leaked within 48 hours was simple. No. Our fastest spacecraft, the Parker Solar Probe, reached about 43,000 miles per hour. Impressive, but it achieved that by falling toward the sun and riding gravity assists. 3I Chi. Atlas maintains comparable speeds while maneuvering freely in any direction. Our missiles can't reach it. Our rockets can't catch it. Our kinetic impactors, the kind used to nudge an asteroid, would take months to arrive, and it could just step aside. Colonel Sarah Martinez put it carefully in a congressional briefing. Our current space assets are designed for satellite defense and tracking near-Earth objects. We have no capability to intercept or engage a maneuvering target at interplanetary distances. If engagement were necessary, purely hypothetical, we would require technologies we do not possess. Translation: we are helpless. Fact 6. Every scenario depends on assumptions we can't verify. And here, the story turns philosophical. Every possible frame: peaceful contact, scientific observation, resource extraction. Colonization requires us to guess the motivations of something we can barely describe. Dr. Lisa Hammond assembled a think tank at Oxford on March 25th. Biologists, psychologists, anthropologists, philosophers, their assignment: predict possible intentions based on observed behavior. The report, delivered 72 hours later, ran 200 pages. The conclusion took 2 paragraphs. We have insufficient data to predict intentions with any confidence. Human history shows that contact between civilizations with large technological disparities typically ends poorly for the less advanced civilization. However, applying human historical patterns to a non-human intelligence is methodologically unsound. We simply do not know. Recommendation: prepare for all scenarios simultaneously. Hope for the best. Prepare for the worst. Acknowledge we cannot reliably distinguish between the two until events unfold. In other words, we have no idea. And maybe that's the most terrifying fact of all. Because in those emergency meetings, under the cold glow of screens and graphs, one truth kept returning. 3I. Atlas holds every card. It chose when to reveal itself. It chose how to communicate. It's choosing when to arrive and where. We're not participants in first contact. We're observers, or maybe subjects. Something is happening to humanity, not with humanity. On March 26th, Dr. Sarah Chen was cleared of any involvement in the CERN transmission. The investigation continued. But security footage from Geneva showed no human entering or leaving during the relevant window. The burned symbol remained unexplained. That night, Chen did something she hadn't done since college. She went to a church. She's not religious. Her words. But she sat alone in the empty pews of a small chapel near the observatory and just sat, processing. A reporter found her there later. Somehow they always do, and asked, "Dr. Chen, after everything you've seen, everything you know about 3I, Atlas, are you afraid?" Chen was quiet for a long moment. Then she said, "I'm not afraid of what it is. I'm afraid of what it knows. It knows we're fragile. It knows we're divided. It knows we're barely capable of leaving our own planet. And it came here anyway. So the question isn't what it wants. The question is, what does something that advanced want with something as primitive as us?" The reporter tried a follow-up. But Chen was done talking. She was staring at her phone at a new email from an unknown sender. Subject line April 23rd. The message body contained one sentence. Plain text. We've been waiting a long time to meet you. And, attached, a photograph timestamped March 26th. L'Antelling Archewu. Devet Sedeminstirideset per M. A photograph of Earth taken from space, from exactly 2.0 astronomical units away. The exact perspective 3i, Atlas, would have right now. March 28th. L'Antelling Archewu. The world is watching the sky. And humanity, maybe for the first time in history, is collectively remembering, because this isn't the first time we've looked up and wondered. It's not even the first time we've convinced ourselves something impossible was unfolding. The difference is, this time, it's real. Let me take you back. Way back. Itenjube Sanchaba. The War of the Worlds broadcast. October 30th. Halloween Eve. Orson Welles sits in a radio studio in New York and performs H.G. Wells's story as a live news bulletin. Martian cylinders landing in Grover's Mill, New Jersey. Heat rays carving through the countryside. A nation supposedly panicking, except there was no panic in the streets. Not really. That's the myth. What actually happened is more interesting and more relevant to where we are now. About 2% of listeners, roughly 2 million people, believed it was real. Not because they were foolish, but because the broadcast was convincing, the format familiar, and the idea of life on Mars was, at the time, scientifically plausible. In 1938, we didn't yet know Mars was a frozen desert. We didn't have rovers or orbiters photographing its surface. But here's what mattered. Most people who believed it wasn't real didn't riot. They called police stations. They called newspapers. They searched for confirmation. They tried to verify. The human response to potential alien contact wasn't hysteria. It was curiosity and caution. Dr. Cynthia Weber, a political scientist at the University of Sussex, has studied the War of the Worlds response extensively. On March 28th, she published an op-ed in the New York Times. Wells's broadcast taught us that most people faced with extraordinary claims seek verification. The mass panic was exaggerated by newspapers that wanted to discredit radio as a news medium. The real story is quieter. Humans are more rational than we give ourselves credit for. And right now, in 2025, we're watching that play out again. Itenjo by Sishati. Roswell and the birth of modern UFO culture. July 1947. Something crashes on a ranch near Roswell, New Mexico. The Army Air Forces initially report recovering a flying disc. Then, within 24 hours, they change the story. It was a weather balloon. For decades, conspiracy theories bloom. What did they really find? Was it a craft? Were there bodies? What's the government hiding? Then, in 1994, the Air Force declassified the truth. It was Project Mogul, a classified program using high-altitude balloons to detect Soviet nuclear tests. Not aliens. Not a weather balloon. Something in between. Something so secret the cover story had to be painfully ordinary. Dr. Richard Dolan, a historian of Cold War secrecy, points out the parallel. The government chose a mundane cover story because the truth was classified, but still human. With 3i, Atlas, we're in the opposite situation. The truth is extraordinary, and there's no believable cover story. So we're stuck with transparency by necessity, and that transparency is unprecedented. Every major space agency is publishing data daily. Academic papers are appearing on RxIV hours after observations are made. Press conferences happen every 48 hours. Why? Because unlike 1947, we can't control the narrative. Too many independent observers, too many amateurs, too many backyard telescopes aimed at the same moving star. The secret can't be kept because there are a million witnesses. Itenjo by Tishitsi. The WOW signal. August 15th. Itenjo by Tishitsi. The Big Ear radio telescope at Ohio State detects a strong narrowband radio signal from Sagittarius. It lasts 72 seconds. Dr. Jerry Eman reviews the printout and writes, "Wow" in the margin. the signal never repeats. For decades, we debated what it was: natural phenomenon, interference, or something else entirely. And after it, nothing. The world didn't change. There was no panic. SETI kept listening. Life went on. Because one unexplained blip, however thrilling, wasn't enough to reshape civilization. Dr. Jill Tarter, who spent 4 decades searching for signals like wow, reflected on this in a CNN interview on March 29th. The wow signal taught us that we wanted proof. We wanted repeatability. We wanted something undeniable. Well, now we have it. And I think we're discovering we weren't as ready as we thought. Because 3I, Atlas, isn't a maybe. It's not a single blip. It's continuous, repeating, approaching, undeniable. Downtelling Ishuti, Oumuamua, and the question we should have asked. October 2017. Astronomers detect the first confirmed interstellar object passing through our solar system. Elongated, tumbling, slightly accelerating as it leaves, suggesting outgassing or something stranger. Harvard astrophysicist Avi Loeb suggests, cautiously, that it might be artificial, a light sail, perhaps technology. The scientific community responds with skepticism. Loeb is criticized for speculation, for leaping too quickly, for not following Occam's razor. 8 years later, on March 30th, Downtelling Arshawu, Loeb publishes an essay titled, "We Should Have Looked Harder." In it, he writes that Oumuamua was a warning shot, an object with anomalous properties that stretched our models. We explained it away because we preferred natural explanations, because we weren't ready to consider alternatives. But what if that preference made us miss the obvious? What if Oumuamua was a scout probe, and we let it pass without serious investigation because we were afraid of seeming foolish? It's a haunting thought. What if we've already been visited before, and we just didn't notice science fiction versus reality? The contact paradox. Humanity has imagined alien contact for over a century. H. G. Wells, Arthur C. Clarke, Carl Sagan. Arrival. Contact. The expanse. Thousands of scenarios, countless possibilities. And yet, when it actually happens, none of our fiction prepares us. In movies, aliens arrive in obvious shapes, giant ships above cities. Transmissions in English, clear intentions, usually invasion, sometimes peace. Contact arrives in the third act. By the credits, we understand what they want. But 3I, Atlas, it's been here for 8 months. And we still don't know why. It offered a mathematical greeting, and then nothing more. It's approaching Earth but not threatening, demonstrating intelligence but not explaining itself, prolonging the ambiguity. And that ambiguity is what unsettles us most. Dr. Ted Chiang, the science fiction author who wrote Story of Your Life, adapted into Arrival, was interviewed by NPR on March 31st. His observation was striking. In Arrival, the aliens arrive and immediately begin teaching language. Communication starts within days. But that's fiction. In reality, 3II. Atlas is showing us that first contact might not be about communication at all. It might be about observation, assessment, patience. The aliens in my story needed something from humans, so they engaged. Chiang said, but what if they don't need anything? What if we're just interesting to them? That question, what then, has kept philosophers awake at night. The social media factor, a new variable. Here's something no previous generation had to endure instant. Global, unfiltered communication. By April 1st, number 3, iAtlas is trending worldwide. Every platform, Twitter, Instagram, TikTok, Reddit flooded with content. Memes, mostly jokes about alien tourists. Conspiracy theories ranging from plausible to absurd. Amateur videos of people filming the night sky. Fake leaked documents. AI-generated images claiming to show the object up close. But something else is happening. 2. Something unprecedented. A shared experience. 7 billion people looking up at the same sky, asking the same questions, feeling the same blend of wonder and quiet dread. Previous generations lived through world-changing moments through newspapers, radio, television mediated, filtered, delayed, always a step behind the moment itself. We're experiencing this in real time, together, commenting, to reacting, translating, arguing, comforting, processing as one enormous nervous system. Dr. Dana Boyd, yes, lowercase. That's how she spells it. A social media researcher at Microsoft published a rapid response study on April 2nd. Social media, she wrote, is creating a global conversation that is simultaneously unifying and fragmenting. We're all watching 3-2, Atlas, but we're interpreting it through millions of different cultural, religious, and philosophical lenses. The result is a rare consensus that something significant is happening and a complete disagreement about what it means. In Jakarta, people are praying. In Mumbai, celebrating. In New York, protesting, though what they're protesting isn't entirely clear. In Tokyo, preparing. In São Paulo, planning. In Lagos, partying. In Sydney, debating. Watching everyone doing something, nobody doing nothing, and that might be the most important difference between now and every other moment in human history. When Orson Welles broadcast War of the Worlds, most people weren't listening. When Roswell happened, it was a local story for days. When the WOW signal was detected, most people never heard about it. When Oumuamua passed through, it was a curiosity for astronomy enthusiasts. But 3-2, Atlas, the whole world is watching. On April Triad, Dr. Sarah Chen received another email, same unknown sender. Subject line, you're asking the right questions. Message, body 1938. They imagined invasion. Itenjo by Sishuti. They feared invasion. Itenjo by Tishuti. They hoped for contact. Liaotenling Ishuti. They missed us. Liaotenling Oshawu. They're ready. Yu Chen forwarded it to NASA security. They traced the IP address to a server farm in Iceland. Dead end. Whoever was sending these messages knew exactly how to vanish. But the message itself wouldn't stop echoing in her mind. They're ready. Not you're ready. They're ready. Who's they, humanity? Or something else entirely? 20 days until closest approach. 20 days to learn whether everything we think we learned from history means anything at all. April 5th. Liaotenling Oshawu. Dr. Sarah Chen stands in front of the United Nations General Assembly. Not physically. She's video conferencing from Hawaii because leaving the observatory right now feels impossible, like stepping away from a shoreline as a tide is rising. But her face fills a giant screen, and every seat is filled. Every member state sent representatives, even the ones who haven't agreed on anything in decades. She's not there to present data. Plenty of people have done that already. She's there to answer one question, posed by the Secretary General himself. Dr. Chen, in your expert opinion, what does this mean for humanity? She takes a breath, and then she says something that will be quoted for generations. It means we were never alone. It means the universe was watching. And it means that everything, absolutely everything about how we see ourselves, our place in the cosmos, our future as a species, that all changes today. Let's talk about what that actually means. Not in abstract philosophy, but in concrete, practical, life-altering ways. The philosophical earthquake. For thousands of years, humans have asked, are we alone? Every religion, every philosophy, every culture has wrestled with that question. Many answered with gods, spirits, angels, demons, ancestors watching from the sky. But modern science pushed back, show us evidence, show us proof. And for a long time, we never found it. SETI listened for decades. Silence. Space probes explored the solar system. Nothing. Exoplanet discoveries climbed into the thousands, but no signals. No visitors. No confirmation until now. Dr. Michael Shermer, a science historian and longtime skeptic of UFO claims, published an essay on April 6th titled The Death of Cosmic Loneliness. In it, he writes, "For 400 years since Copernicus, science has been systematically demoting humanity from the center of everything. Earth isn't the center of the universe. The sun is just one star among billions. Our galaxy is one of trillions. We accepted our cosmic insignificance intellectually, but emotionally we still felt special, unique, the only consciousness in an unconscious universe. That feeling dies today. We are not special. We are not unique. We are one of how many? Thousands, millions. We have no idea. But we're definitely not alone." Religious leaders worldwide scramble to respond. Pope Francis, in an emergency address from Vatican City on April 7th, says, "The existence of intelligent life beyond Earth does not contradict faith. If God created the vastness of the universe, why would we assume he stopped with only us? This is not a crisis of faith. This is an expansion of wonder." The Dalai Lama, reached by journalists in Dharamsala, offers a simpler response. Of course, there are others. The universe is infinite. Consciousness is infinite. This confirms what Buddhism has taught for millennia, but not everyone is handling it so calmly. Evangelical churches in the United States see attendance spike by 40% in the first week of April. Some preachers call it the end times. Others call it a test of faith. A few, and this surprises people, call it an opportunity. Reverend Marcus Cole from a megachurch in Houston says in his Sunday sermon, "Maybe God didn't just make us in his image. Maybe he made many in his image. Maybe we're about to meet our brothers and sisters from another world." Meanwhile, atheist communities face their own reckoning. The American Humanist Association releases a statement, "The existence of extraterrestrial intelligence doesn't change our values or our ethics. We're still responsible for each other, for our planet, for our future. If anything, this makes our commitment to reason and evidence more important than ever." The technology gap. How far behind are we? Let's get brutally honest. The technology demonstrated by 3A Chi, Atlas gravitational wave manipulation, sustained multi-megawatt power generation in a compact form, propulsion with specific impulse thousands of times better than ours, represents a gap that's hard to even name without losing your breath. Dr. Michio Kaku, theoretical physicist and futurist, appears on every news network during the first week of April. His message is consistent. On the Kardashev scale, measuring advancement by energy use, humanity is about 0. We use a fraction of our planet's energy. A Type 1 civilization uses all their planet's energy. Type 2 uses their star's energy. Type 3 uses their galaxy's energy. He pauses in one CBS Evening News interview and adds 3I, Atlas, based on what we're observing. At least, Type 1. 5. Maybe approaching Type 2. The gap between us and them is like the gap between a stone axe and a nuclear reactor. We're not in the same technological century. We're not even in the same technological millennium. That's sobering. But here's what's really keeping scientists and military strategists awake. If the gap is that large, then everything we think we know about security, defense, sovereignty, power becomes obsolete overnight. Dr. Elena Volkov put it bluntly in a closed-door briefing with Russian officials, which was immediately leaked. If they wanted our resources, they'd take them. If they wanted our planet, we couldn't stop them. The only reason we still have agency is because they're choosing to give it to us. We exist at their discretion. The Pentagon runs scenarios. The Chinese military runs scenarios. NATO runs scenarios. The results are the same in any conflict scenario. Humanity loses completely immediately. And strangely, that realization begins to pull humanity together in ways nothing else ever has. The geopolitical shift, borders becoming less meaningful. April 8th. Lansinling Arshawu. Something extraordinary happens at the United Nations. The Security Council, the 5 permanent members who rarely agree on anything, unanimously passes Resolution 2847, the establishment of the Unified Earth Contact Initiative. Not just a resolution, a framework, a commitment. All space agencies will share data on 3I, Atlas completely and immediately. No classified information, no national security exemptions. Everything public, everything transparent. All military space assets will be placed under temporary international coordination. Not control, nobody's giving up sovereignty, but coordination, so we don't look like a fractured bee. Primitive species incapable of working together. All responses to 3I, Atlas will be made collectively representing Earth, not individual nations. The vote is 15-0. No abstentions. China and the United States, who haven't agreed on anything substantial in years, both vote yes. Russia and the UK. France, and whoever holds the rotating seats, everyone, because faced with something beyond Earth, national borders suddenly feel arbitrary, almost silly. Even Dr. Naif Al-Rodan, a philosopher and geopolitical expert at directing, writes in Foreign Affairs, for the first time since the nation, all responses to 3I, Atlas would be issued as one voice, representing Earth as a whole, not any single nation. The vote landed 15-0, with no abstentions. China and the United States, who hadn't agreed on anything substantial in years, both said yes. Russia and the UK. France and whoever held the rotating seats, everyone. Because faced with something beyond Earth, borders suddenly felt small, almost silly. Even Dr. Naif Al-Rodan, a philosopher and geopolitical expert, wrote in Foreign Affairs that for the first time since the nation-state system emerged, we were confronting a challenge that made nationality feel irrelevant. 3I, Atlas didn't care about our borders, our flags, our old grievances. It saw one species on one planet, and for a moment, the old map lines blurred in our minds. And maybe that perspective, seeing ourselves as one species, under one sky, was the real gift hidden inside the dread. But not everyone welcomed it. Nationalist movements worldwide called it a threat. Don't surrender our sovereignty to unelected global bureaucrats. The phrase became a rallying cry in several countries. Protests flared in Paris, Washington, Moscow, Beijing. People who'd spent years fighting globalization treated this as the ultimate globalist conspiracy. And the streets filled with noise. The conspiracy theories, as always, were inventive. Some insisted 3I, Atlas, was a government hoax meant to justify a new world order. Others said it was real but cooperating with specific governments. One popular claim in darker corners of the internet, 3I, Atlas, was actually a Chinese or American craft dressed up as alien so someone could unite the world under their control. The evidence against those stories was overwhelming, thousands of independent observations, rival nations confirming the same measurements. But evidence doesn't always win when people are frightened. The economic world didn't know how to breathe. When Wall Street opened on April 9th, it was chaos. Some sectors plunged hard, screens flashing red like warning lights. Airlines saw a 30% drop. Why fly if we might be making contact with beings who cross interstellar space? Space tourism names Blue Origin, Virgin Galactic watched their stocks collapse. Who wanted the edge of space when something had come from beyond it? Other sectors leapt upward. Defense contractors climbed 45%. Telecommunications companies surged. Any company with space or technology in its name drew speculative money. Yet the strangest part was this overall market volatility stayed lower than expected. The Dow fell 8% in the first 2 days, then steadied. The global economy didn't collapse. People still went to work. Grocery stores stayed stocked. Lights stayed on. The ordinary world kept its rhythm, almost stubbornly. Infrastructure kept running. Dr. Esther Duflo, Nobel laureate in economics, explained it on Bloomberg. Markets hate uncertainty, but they also adapt. Yes, we were in uncertain times, but 3I, Atlas, wasn't attacking, wasn't disrupting supply chains, wasn't causing immediate economic damage. So markets priced in uncertainty, not catastrophe. It was, she said, strangely fascinating. Humanity's economic systems were proving more resilient than we expected, though, she added. Ask me again on April 24. If something happened at closest approach, all bets were off. And then there was the individual response, how people were actually handling this. Here's what surprised everyone. Most people were okay, not thrilled, not indifferent, just okay. Suicide rates didn't spike. Crime didn't explode. Society didn't collapse. People still went to work, picked up their kids, watched Netflix, argued about sports. Dr. Steven Pinker, a cognitive psychologist at Harvard, noted, "Humans are remarkably adaptable. We normalize the extraordinary faster than we think. A century ago, flying across the Atlantic was miraculous. Now it's boring. We do the same with this." In 6 months, there would be 3I Atlas memes. In a year, people would complain that alien contact hadn't immediately given us warp drives and teleporters. Still, there were changes, quiet ones, like soft pressure on the heart. Church attendance rose. Volunteering rose. Charitable donations jumped 23% in the first week of April. People called old friends. They made peace with estranged family, what psychologists started calling cosmic perspective taking. Faced with something vast and unknown, humans remembered what actually mattered, and the remembering spread. And weirdly, wonderfully, people were kinder. Road rage incidents fell. Customer service complaints dropped. It was as if everyone quietly agreed, if we're about to meet aliens, let's at least not be cruel to each other. On April 11th, a video went viral. A high school student in Ohio filmed herself and her dad watching the night sky. They were looking for 3I Atlas. It was visible now, a bright star moving slowly against the background. And the girl spoke so softly the microphone barely caught it. "Dad, what if they're just like us?" Looking up at their sky, wondering if anyone's out there, and they found us. Her dad didn't answer for a long moment. Then he said, "Then maybe we should make a good first impression." The clip hit 200 million views in 48 hours. Because maybe that was the real implication, not philosophy, not technology, not geopolitics. Maybe it was this: we were being watched, evaluated, given a chance to show what kind of species we are, in the gentlest possible spotlight. And for the first time in human history, the whole world wondered the same thing. Would we be worth meeting? It hung in the quiet like a question whispered into a pillow. 12 days until closest approach. 12 days to decide. April 12th, 2025, 11 days out. Dr. Sarah Chen hadn't slept more than 3 hours a night in 2 weeks. And she wasn't alone. Across the globe, in observatories and space agencies, control rooms and universities, thousands of scientists lived on caffeine, adrenaline, and the steady knowledge that they were inside the most significant moment in human history. And they could do nothing but watch. 3I Atlas was now 2 astronomical units from Earth, about 111 million miles. Still far, but close enough that amateur telescopes could resolve it as more than a point of light. It looked elongated, rotating slowly, and that hotspot on the aft section still glowed in infrared. Steady as a heartbeat you can't ignore. The object hadn't sent any new transmissions since March 14th. No follow-ups. No response to the unauthorized CERN broadcast. No reply to the dozens of signals governments, organizations, even individuals had aimed at it, only silence and approach. The global vigil held nearly every telescope on Earth was pointed at 3I Atlas. Not just the professional ones, amateurs, too, right now. As you're hearing this, telescope feeds stream live on YouTube, on Twitch, on every platform imaginable. Millions watch a bright dot move impossibly slowly across the starfield. A steady glide that holds attention like a lullaby. It becomes the most watched event in human history, more than the moon landing, more than any World Cup final, more than any Olympic opening ceremony. People set up watch parties. They projected telescope feeds onto building walls in cities worldwide, Times Square, Shibuya Crossing, Piccadilly Circus, each showing the same image, 3I Atlas approaching. The International Astronomical Union established a 24/7 monitoring protocol. Every hour, a different observatory filed a report. Position, velocity, spectroscopy, radio emissions, infrared signature, gravitational effects uploaded immediately to a public database. Why public? Dr. Chen explained it at a press conference on April 13th because this didn't belong to scientists. It didn't belong to governments. It belonged to humanity. Everyone deserved to see what was happening as it happened. No secrets. No classifications, just truth. And the truth, for now, was that 3I, Atlas simply continued its approach steady, predictable, following the trajectory calculated weeks earlier. But was predictable comforting, or was it more unsettling when something this advanced did exactly what you expected because it wanted you to expect it? They were controlling the narrative, managing the encounter. We weren't having first contact. We were being granted first contact. On April 14th, 9 days out, NASA activated what it called the Contact Readiness Framework. It sounded official, almost reassuring, like a thin blanket pulled over a trembling room. But everyone involved knew it was improvisation, dressed in acronyms. The framework had 3 phases. Phase 1, observation only. Continue tracking. No active signaling unless 3I, Atlas, initiated communication. That's where we were. Phase 2, responsive communication. If 3I, Atlas, signaled again. To respond through the International Committee with pre-approved mathematical messages, show we understand, show we're coherent, show we're trying. Phase 3 was where the document turned vague, adaptive response based on scenario development. Translation, we'll figure it out when it happens. Because we don't know what to prepare for. Dr. Marcus Webb at MIT was asked on radio, "Are we ready for Phase 3? He answered, "No, nobody could be. You can't prepare for the unknown. You can only prepare to stay flexible when the unknown arrives." Meanwhile, the European Space Agency's tracking station in Australia ran continuous observations. The lead astronomer there, Dr. Patricia Okoye, I noticed something on April 15th that sent ripples through the community. 3I. Atlas's rotation had slowed again. First observed in January, it rotated once every 7 hours. By March, every 9 hours. Now every 7. 1 hour's still slowing, still changing. And the strange part was how it slowed in discrete steps. Not gradually. Every few days, it dropped by exactly 0. 1 hour's precise. Deliberate, like someone adjusting a dial. It was still communicating. Dr. Okoye told her team, not with transmissions, with behavior. It's showing us it has control. Fine control. It's not drifting. It's not malfunctioning. Everything it does is intentional. And out in the public world, the countdown had begun. Someone built a website, Days Until 3I, Atlas, just a clean timer. The numbers ticking down like a calm metronome in the dark. It becomes the most visited website on Earth. Billions of hits every day. People refresh it compulsively, as if the numbers might shift, as if April 23rd could somehow arrive early or be delayed. Social media turns into a strange braid of anticipation and anxiety. The memes keep coming. Alien tourists taking selfies with Earth, ET phone home jokes, photoshopped shots of 3I, Atlas with googly eyes. Humor as a coping mechanism. Gentle. Human. Familiar. But there are serious posts too. People sharing what they hope to tell their grandchildren about this moment. People writing letters to potential visitors, thousands of them uploaded to a collaborative site, a digital message in a bottle, just in case anyone is listening. A 12-year-old girl in Kenya writes, "Dear visitors from far away, welcome to Earth. We're not perfect, but we're trying. Please be patient with us." An elderly man in Japan writes, "I'm 94 years old. I never thought I'd see this day. Thank you for letting me witness it before I go." A teacher in Brazil writes, "To whoever's out there, I teach children about the universe. Can you help me show them how big and wonderful it really is?" Reading these, you realize most people aren't afraid. Not really. They're hopeful, curious. a little nervous. Like before a first meeting you've imagined your whole life. We're about to meet someone new, and we want quietly to make a good first impression. Behind the public optimism, the scientific scenarios keep running. Scientists model every possibility, every branch in the dark. Scenario A, a flyby observation. 3I, Atlas reaches closest approach, studies Earth in detail, then continues out of the solar system. We confirm alien intelligence exists, but we don't interact beyond that. Probability 40%. Scenario B, a communication attempt. 3I, Atlas sends a more detailed message at closest approach. When signal delay is minimized, we engage in a basic exchange of information. First real contact, probability 35%. Scenario C, probe deployment. 3I, Atlas releases smaller object satellites, probes something into Earth orbit, or even toward the surface. Direct investigation. This is the scenario that makes military strategists uneasy. Probability 15%. Scenario D, nothing. It maintains silence, passes by, and we never understand why it came. That might be the most frustrating outcome of all. Probability 9%. Scenario E, listed only as undefined contingencies. Nobody wants to spell out what those might be. Probability 1%. Dr. Elena Vulov, in a rare moment of late-night candor, says, all our scenarios assume they think like us, assume they value communication, observation, interaction. But what if they don't? What if their purpose is so alien, so different, that our scenarios are like ants, trying to predict why a human is walking across their anthill? No one has a good answer, and the final week arrives. April 16th, 7 days out, 3I. Atlas is bright enough now that you don't need a telescope. Just step outside after sunset, look toward Virgo, and you'll see it brighter than any star except Sirius moving slowly, but visibly. Over the course of an hour, churches, mosques, synagogues, temples, all holding services focused on this cosmic moment. Some preach caution, some preach celebration, most preach unity. The Dalai Lama and Pope Francis release a joint statement on April 17th, the first joint statement they've ever made. It's brief, to our brothers and sisters across Earth, whatever arrives. We face it together. Let compassion guide us. Let curiosity drive us. Let wisdom protect us. We are one human family, and this moment belongs to all of us. April 18th, 5 days out. Stock markets stabilize. Governments stop issuing daily press releases. There's nothing new to say. The world settles into a strange calm. The calm before what? Nobody knows. Then Dr. Sarah Chen receives another email from the same unknown sender. Subject line, final message before arrival. She almost doesn't open it. Almost, but curiosity wins. It always does. The body reads, Dr. Chen, you've been asking good questions. Here's one more. What if we didn't come to observe you? What if we came because you called us? Every radio transmission, every space probe, every signal you've sent into space for the past century, we heard them. All of them. You reached out. We're reaching back. April Doazet she triad 1437 UTC. Be watching, not the sky. The signal. We're not done talking. We're just getting started. No signature. No trace. Just those words. Chen sits in her office, staring at the screen's pale glow. Then she does something she hasn't done in weeks. She smiles. Because maybe the fear, the anxiety, the not knowing, maybe it was never the point. Maybe humanity spent so long asking if we were alone that we forgot the deeper question, what happens when we're not April 23rd? 1437 UTC. You're living through it right now. Whether you're listening in bed, in your car, at work, wherever you are, you're living through the moment when humanity stops being alone in the universe. Every telescope is pointed at 3I Atlas. Every space agency is listening. Every government is watching. And in observatories around the world, scientists wait not with dread, not with fear, but with a careful kind of anticipation. Because for the first time in human history, we're about to hear what someone else has to say. Someone from out there, someone who crossed the vast quiet between stars to find us. And maybe, just maybe, they carry answers to questions we've asked since the first human looked up and wondered, "Is anyone there, Doctor?" Chen adjusts her headset. Her screen shows the gravitational wave detector readings, a calm line, trembling with possibility. Any second now. The clock reads 143700. The detector spikes. Here we go. Whatever happens next, whatever they say, whatever they want, whatever changes, we face it together. 7 billion humans on one small blue planet, looking up at the sky, and finally getting an answer to the oldest question we've ever asked. We are not alone. We never were. And now we get to learn what that truly means. Thank you for joining me on this journey through one of the most profound moments in human history, a moment that is still unfolding. If this story moved you, if it made you think, if it made you look up a little differently, then subscribe to this channel, hit that bell, share this with someone who loves science, someone who wonders about the cosmos, someone who asks the big questions, and tell me, where were you when you listened to this? What are you feeling right now? Drop a comment below. Let's wonder together. Until next time, keep looking up, because now, more than ever, something might be looking back.